Hello everybody, so today I will talk about calculus. The topic today is about Rolle's theorem. So now I will show you how to answer. Let ABCD be distinct real numbers. We have this equation in here. They want to mention has exactly three distinct real solutions. So they provide a hint. We have this equation in here. We know that when we put bs equals to number 0, so this one, that's about this equation, should be equals to number 0. The question, how many distinct real solution answer for, because we will have about s minus a equal to number 0, s minus b equal to number 0, s minus c equals to number 0, and s minus d equals to number 0. So that means we will have about s equals to a, b, c, and d. So that's why we have 4 solutions. Now the next one, then use about logarithmic differentiation. That means I will put about natural log for the both sides. So we have the formula in here. That is about ln a, b, c, and so on into n. We have ln a plus ln b, and so on until ln n. So we will apply this formula for this one. So we will have about ln of bs equals to ln of s minus a plus ln of s minus b, ln of s minus c, and ln of s minus d. So if we do first derivative for the both sides, this one you got about first derivative of b of s over bs. So first derivative of this one, you got about 1 over s minus a. Similar for the next one. Later that we multiply both sides by bs. We know that bs, that is about this one. So if we put this bs divided by s minus a, s minus b, s minus c, and s minus d, so they will got the same with this equation in here. So I need to copy this one and I will put in here. Now the next one, we need to apply about Rolle's theorem. Now let's say I will put the order A, B, C, D in this order like this. and we will have about the interval from a to d. According to this one, bs, this function is about continuous from negative infinity to positive infinity. So because they continue on the real number, so this interval should be about continuous. Because this interval is continuous, so that means we will have about the interval from a to b, b to c, and c to d. They are continuous too. Next, we see that this function can do about differentiation. So that means all of them from a to d, they can do about differentiation. And we will have about similar from a to b, b to c, and c to d. They are differentiation too. And the last one, we have b of a equals to b of b equals to b of c equals to b of d equals to number 0, because a, b, c, d, they are solution of bs. So we see that we have 3 conditions of Rolle's theorem. So now I will wrap about the function in here. We know that the highest power of bs, that's about s to the power of 4. So we know that coefficient is about 1, 1, 1, and 1. So this should be about 1. Number 1 is about positive. So with about even power, when s approaches to positive or negative infinity, they will go to positive infinity. So the graph of this bs should be like this. For example, I will put about a, b, c, d in here. The graph should be like this. So we see that on this interval, we have 3 critical points. According to about Rolle's theorem, if 3 conditions like this they are satisfied, so that means at least there are at least 1 critical point exists between a to b, b to c, c to d. So I will put about like this. I will put about e, that's the location of e in here. This is about f, and this one is about g. So we see that we have 3 critical points of the function p of s. So that means we will have about 3 solutions of this one, because we have 3 critical points represent about 3 solutions of first derivative of b of s. And this is the answer for the question in here. This is the end. Thank you for watching.